All right, here we go. So we're going to review chapter 2, and I'm actually going to use your guys' boards to review chapter 2. So I'm going to try to get this a little closer so we make sure that it's pretty clear as possible. Go ahead and turn in your book to 2-1, and that way you can follow along with this as well as you can. You can see we're doing the property of addition. We've got associative, which is changing the grouping of addends, does not change the sum. Addends are the parts of addition. Sum is the answer to addition. So you can see on the example, the first example they put here, it says in parentheses -5 plus 4 in parentheses plus 6 equals -5 plus, in parentheses, there should be another parenthesis here, 4 plus 6. So you can see that you can move the parentheses if you have them in the same order. Same with example 2. The -2 comes before the 4 plus 6. You could have 6 plus -2 plus 4, which actually this isn't the right way to put it. You should have -2 plus 4 first, and then the 6 to really show the associative. And then that's not associative. So just so you know. Inverse. Inverse is the sum of any integers and its additive inverse is equals 0, the additive element of the identity element of addition. That is confusing to most students. Basically, it's you add two numbers and get 0. So you're going to have the number and its opposite. If you remember when we played around with the number line, that's what the inverse was. All right, next we're going to switch over to the rest of the property of addition. All right, we've got commutative and identity property. So when they said identity for inverse, that wasn't true, because identity is where you're starting with a number and then ending up with a number. So we have this in both addition and multiplication. So when you start with one number and you end with the same number you started with, that's what makes it identity. Commutative, changing the order of the addends does not change the sum. So if we go 3 plus 5 equals 5 plus 3, that's right. Doesn't matter what order these are in, you're still going to get the same answer. And they've got a bunch of different examples to show you. Identity is basically take a number plus 0. That's the additive identity. So that's 2.1. You've got to remember the names of those and what they do. Remember the big difference between associative and commutative when you see it on a test is associative is got the same order of numbers, but you just switch which ones you're adding. On commutative, you're switching the order. That's the big difference. All right, that's the end of 2.1. 2-2 takes property of addition to multiplication. So all the properties from addition go over to multiplication. So we'll just kind of look at their stuff down here. So they repeated themselves down here. So these are what's up here. So closure, again, I don't really test on that, so you won't see it on the test. So you can look at it in your book if you're really curious. Commutative, remember you can change the order. Associative is you're changing the grouping of the factors. So they're still in the same order, you're just changing the grouping. And you can see their examples are right over here. You also have examples in your book. You should be following along in your book. I don't know how to make that more clear. Identity property, again, you're starting with a number and then ending with that same number. So the way to do that with multiplication is multiplying by 1. 0, anytime you multiply by 0, you get 0. So that is the 0 identity of multiplication. Make sure you put identity of multiplication, associative of multiplication, commutative of multiplication, so that you can differentiate between multiplication and addition on the test. All right, that's 2.2. All right, after all that commutative and so on and so forth, we get to distributive property, and it has its own section, 2.3. Distributive, you'll see a lot in your math career. Following example illustrates the distributive property. So they're just showing you that if you got something outside the parentheses, you're going to multiply it to both of them when there's addition or subtraction. So the 3 goes to the 2, 3 goes to the 5. Remember, we can do that kind of rainbow thing to to do it. Make sure you always get the number to the last one as well. That's one that students make mistakes on. So 3 times 2 is 6, 3 times 5 is 15. You could do the parentheses first, but that's not distributive property. This is distributive property. And coming down this way, that's distributive property. This is just simply doing the parentheses first. This gets you the answer. This illustrates the distributive property because you can't do this if they're not like terms in here. So if we had like 2x and 5, that's why we're learning the distributive property this way, so that once you get to the 2x and the 5, like you have for chapter 3, then you know how to do it. They have some more examples I can show you. So there's some more examples. Or another example for you with the 3, 8, and 5. Remember, don't do this for distributive. You do this for distributive, where you put the to the 8 to the 5, you get 24, you get 15, you get 9. This side is not distributive. This is distributive property. All right. All right, for 2.4, we have evaluating expressions. And this is the beginning of the algebra that we started to do. You've got numbers, variables, and signs in it. Remember, at this point, we started to learn terms. So you've got your constant, which is the number by itself. You've got your coefficient, which is the number that comes before the n. So there's no number here. Oh, what's the magic number that goes there? It's a 1. Remember that. That's that identity sort of thing. But that's something we definitely got to remember. Down here, the coefficient is 5. And then the number of terms, we have 1, 2 terms. And then the variable is obviously n. So you can see with this example, we plug in 2 for n. Now the n becomes a 2. 4 plus 2 is 6. You can see b is 10, and so on and so forth. And then they've got other examples here where you've got multiple ones you got to plug in. Just make sure that goes to the F, this goes to the A, so on and so forth. They've got those examples as well. So there you go. Evaluating expressions, that's 2.4. Next is simplifying expressions. You see, this is the simplifying expressions. This is actually where we learn the terms. I'm sorry. Constant, term, coefficient, and variables. So make sure you know what those are. It's best to make flashcards if you don't know them by heart. The steps that you take for simplifying expressions, regroup using the associative property. In this case, this is 4 times 3 times x. So instead of doing 3 times x first, they do 4 times 3 first, and that's how you get 12. You could also think of this, because multiplication is distributive, you distribute it in, but you only do it to the 3 because the 3x is one term. You don't have to go to the 4 to the 3, 4 to the x. You would do that if it was 3 plus x, but it's 4 3 times x. So hopefully that helps. Here's another example over here where it has 7 times 5x, and then you make it 7 times 5x, which is 35x. And I think this is a great question down here. So you should pause the video and try that one right there on the bottom. This one, try this. What are the constants, coefficients, and variables in each of those expressions? Hint, there are no constants in any of these examples. And coefficients are created after you do the associative property and then combine like terms. Actually, you wouldn't combine like terms until the end. So this one down here will have 3 coefficients, and obviously the variable is x. This one will have 1 where you multiply that together. This multiplied together is a coefficient. This multiplied together is a coefficient. If we added 2 to this, that would be the constant, with 2 by itself. All right. So 2.6 and 2.7 are videos I've done that are already on RenWeb. Definitely look over those as well. You will have a cumulative assignment for all of Chapter 2 to get you ready for the retake. Hopefully you're finishing up your test corrections, and everybody will take the opportunity to do the retake. Thank you so much. See you later.